This unit is on probability. We may not be able to predict a particular individual outcome, such as how a flipped coin will land, but we're reasonably sure that a fair coin will land heads about half the time in the long run. The probability of an event is its long run frequency. Let's look at an example. So what's the probability a tack will land point down? Well, let's do our trial of 10. You can do it at home if you have a tack. There's 1. There's 2. There's 3. Not us so far. There's 4. There's 5 tosses, and notice it's tacked down, so that's 1 out of 5. Here comes toss 6. Nope. Toss 7. Yes, so that's 2 out of 7. Toss 8. Yes, that's 3 out of 8. Nope. 3 out of 9. And our last one, 4 out of 10. So we have 4 out of 10 tosses where the point side is down. So we can finish filling in this chart by doing another set of 10 and another set of 10 and so forth. Here are my results. You can see that I got 5 tosses in my second round of 10, 2 tosses in both my third and fourth rounds, and then 5 in my fifth. And the last column, you're doing the cumulative frequency. So notice for trial 2, I'm combining the 4 out of 5, and it's now out of 20 or 45%. So here are all my percentages. You can use that to create a frequency graph. Here are my values on the chart, and you can definitely see that it looks like the probability is around 40 or kind of between 30 and 50, but this is not really telling us enough about the trend. But if we combine our data with other students in the class or with my kids, toss 1.
Down.
Okay, and toss 2. Ready?
Down.
Down.
Up.
And combining many other groups, our graph changes to this, and you do see more of a pattern. Notice on the first 10 tosses, there's all sorts of different probabilities ranging from 0 point side down to 7 point side down. But if we continue to accumulate our groups of 10, we're ending up more around this kind of mid 30 to 40 area for the probability that the tack will land point side down. This leads us to the law of large numbers, which says, as the number of independent trials increase, the long run probability gets closer and closer to what the true probability is. You need to be careful of the non-existent law of averages. It deals with the short run, and some people believe that if an outcome hasn't occurred in many trials, it's due. But remember, the law of averages is not true. It does not exist. Here are some other basic definitions in probability. A trial is each attempt, the total number of times the experiment is repeated. The outcome is what happens on each trial. Frequency, the number of times a certain outcome occurs. Relative frequency, right, that's going to be your fraction, the frequency of wanted outcomes divided by the total number of outcomes. Now let's look at sample space. Sample space, which is often written with a capital S, is equal to the set of all possible outcomes. But remember, the outcomes must be equally likely to occur. One example, how about if you toss a coin? What's your sample space going to be? It will be HT. Those are all the possible outcomes. How about if you toss 2 coins? What do you think the sample space will be? Did you say heads, heads, tails, tails, heads, tails, and tails, heads? There's 4 members? Then you're correct. Let's try one more. How about the sum of 2 die? What do you think the sample space is going to be? Is this what you thought? Well, you're wrong. Remember, each of the outcomes must be equally likely to occur, and that's not true in this case. You need to think of all the possible ways you can get the sum of 2 die. For example, a 3 is actually created by a 2 plus 1 and a 1 plus 2. So the real sample space for the toss of 2 die would look more like this: 2, 3, 3, 4, 4, 4, all the possible ways that would include getting each value. You might even want to write 2 plus 2, 3 plus 1, 1 plus 3, and so forth. More vocabulary: an event is any outcome or set of outcomes. And then here's the probability of an event, and that's just your basic probability, the number of times the event happens out of the total members of the sample space. For example, let's say you toss a die. Your sample space will be S equal to, there's a 1, a 2, a 3, a 4, a 5, and a 6 on a single die. And let's say I ask for P of multiple of 3. So this is asking for what's the probability of getting a multiple of 3 when you toss a die. A multiple of 3 would mean a 3 or a 6. So there's 2 ways to get that out of a total of 6. Or you could reduce it to 1/3. But get in practice of writing your probability out as P of whatever your event is. So how large is your sample space, or how many possible outcomes do you have? Well, one way to determine it is the fundamental counting principle. If you can do one task a number of ways and a second task b number of ways, then you can do both tasks a and b number of ways. You can use this rule to figure out how large your sample space will be. You could also do a grid method and a tree diagram method. So let's look at all 3 ways to find how big your sample space is going to be. Let's say you have a spinner with 3 parts to it, A, B, and C, equally divided, and a die, and you're going to spin and toss the die. If we use the counting principle to find how big our sample space will be, well, how many ways can you spin the spinner? That's 3. And how many ways can you toss the die? That's 6, which will give you a total of 18 possible outcomes. But sometimes you want more than just the number of outcomes. You want to actually see all the possible outcomes. And that's where our grid or the tree diagram will come in handy. For the grid method, notice here's one event, spinning the spinner, and here's our second event, tossing the die, and we could fill out this chart, A1, A2, A3, and so forth, but notice in these boxes here, there are 18 of them, and it would list every single method. But remember, the grid method only works for 2 events. It doesn't work for more than 2 events. If you want to use more than 2 events, you might want to do a tree diagram. In a tree diagram, you start with one event, and then you branch out from that for all the second events. So here you can see if we combine A with all of these, it would give us our A1, A2, A3, and so forth. And we can see here we have our 18 possible outcomes. But if we had a third event, let's say flipping a coin, we could add that to each one of our numbers here and put heads, tails, etc. And we could have our entire possible outcomes here. Just be careful because you can see right here I started to get kind of sloppy with it. Here actually is a much neater version of it, but you can see along here are listed all of our 36 members of our sample space, and you would read each member as A1 heads, A1 tails, and so forth. Now let's look at some basic probability rules. Here are 4 of the 5 basic rules we'll use in this unit. Rule number 1 says the probability of an event has to be a number between 0 and 1 or including 0 and 1.
Rule number 2, the probability of your sample space is equal to 1 or 100%. Rule number 3, suppose the probability of getting an A in this course is 40%. What's the probability of not getting an A? It's 60, but those are complements of each other. A complement is everything that your event is not, and together they should add to 1. Or P of A is equal to 1 minus the probability of the complement of A, and vice versa. And we can add what we just said, P of A plus P of its complement is equal to 1. Rule number 4 deals with disjoint. Two events are disjoint if they have no outcomes in common. For example, let's say you toss a die. What's the probability of getting a 1 or a 2? Well, getting a 1 or a 2 when you toss a die, they are disjoint. There's no overlap. They cannot happen at the same time. So you're going to just add their separate probabilities together, or 1/6 plus 1/6, which is 2/6 or 1/3. So they are disjoint, and you can add their separate probabilities. Rule 5 we'll discuss later. Take a minute, pause the video, and try answering these 3 problems. Hopefully you got 1/2 for the first problem, 4/6 or 2/3 for problem number 2, and then 3 is dealing with two things that are not disjoint. We will discuss this later, but many of you may have already answered that question and gotten 28 out of 52. Now you can work on the problems. As you work on them, practice writing the questions as well. Practice writing P of whatever it's asking for and then your answer. I'll see you in class soon.